Signals can be divided in two big categories, analog and digital signals. In this lesson, we're going to talk about the difference between the two. Let's start with the analog signals. We have a definition here. Analog signals are signals in which any value of the voltage or the current is used to transmit information at any given time. Even if the voltage on a circuit is limited between two values, for example 0 volts and the value of the battery voltage, there are still infinite possible values of the voltage in between, and each one of them at any single given time is transmitting an information. Let me give you an example. Here I try to represent an audio signal. Audio signal moves smoothly between different values, and we know that each of the points of the curve at any given time is giving us an important information. It's communicating what is the value of the pressure change in the air due to a singer or an instrument. So we don't want to lose any of these points because each one of them is important. Even points that are very close to each other, like this one and this one, they're still carrying a different information that we want to keep, so that our analog signal is as rich as possible. In digital signals, on the contrary, the value of the voltage or the current is used to represent only a finite number of possible values, usually only two. Let me give you an example. This looks like a classic digital signal. The voltage moves rapidly between two possible values, up and down, up and down. The two possible values of the voltage are either called high and low for high voltage and low voltage, or most of the time they're just called 1 and 0. So in this case we have a 0 at the beginning, then it becomes a 1, 0, 1, 0, 1, and 0. Now before we move on, I want to make a very important point. Digital signals tend to look like this. The voltage jumps up and down, but that doesn't mean that the voltage is actually really jumping between the low value and the high value. If you take this edge, for example, and you zoom it, you will see that the voltage is initially low, so it's a 0 logic level. Then it will start rising. It will probably ring a little bit, and then it will settle to the new value, which is the high value, corresponding to a logic 1. Voltages cannot change instantaneously between one value to another. They can't do it physically. So we can say that all signals are continuous and analog in their nature, and really the only difference between analog and digital signal is the different interpretation that we give to the value of the voltage or the current. With analog signals, any value of the voltage or the current at any given time is important and carrying information, while with digital signals we simplify things and we just say that voltages that are high enough are a logic 1, and voltages that are low enough are a logic 0. So for instance, if we look at the zoom waveform that we have here, there is a difference between this point and this point. This point is slightly higher than this other point, but because they're both high enough, there's no difference of information there. They're both logic 1s. How do we determine what is a logic 1 and what is a logic 0? Well, the designer of the circuit will have to define two thresholds. One will be somewhere here, and is usually called VIH, and the other one will be here, and is usually called VIL. Every voltage higher than VIH is a logic 1. Every voltage lower than VIL will be a logic 0. Voltages in between are carrying an undetermined logic state. So it's undesired value for the voltage. And that is one of the reasons why digital signals tend to move as quickly as possible between logic 0 and logic 1. There's no reason for the signal to be in between the thresholds. It's not carrying any information.